Now let's look at the quotient rule. Very much like the product rule, but obviously used for quotients instead of products. So we take the derivative with respect to x of a function of x divided by a function of x. F of x divided by g of x. Looks very similar to the product rule. One important difference is the order. We start always with the bottom non-derivative. So g of x times the derivative of f of x, f prime of x, minus f of x, the derivative of g of x, all divided by g of x function squared. Please make sure you're writing it in that notation. It's different if the squared is here squaring the x. We're not squaring the x, we're squaring the function. Please keep in mind that the denominator, of course, can never equal 0 all the time. Please also notice that we're always starting with the denominator. Also, important note, just like in product rule, think first. Do I need quotient rule? Meaning, does it have to be a quotient? Or, that's right, can I simplify first so it's not a quotient? Because if I can, then I save lots of time. So let's look at these first three examples right here. Differentiating with respect to x. I see division, it's a quotient. Division, it's a quotient. Division, it's a quotient. But in all of these examples, I can simplify first. 1, 2, and 3. In all of these, we can simplify so it's not a quotient. Not question mark, exclamation point. We can do it, we can do it, we can do it. What do we do in this first one to simplify it? That's right, split it up. X squared over x plus 5x over x. That makes x, oops, I said over x, and I wrote over 5. No wonder I was confused. Over x. So x plus 5 is what it makes. There's our function simplified, not a quotient anymore, so I don't need a quotient rule. What's the derivative of x? 1. What's the derivative of 5? 0. Done. Faster than if I tried to turn that into a quotient rule problem. This one also can be simplified. Write it as a negative exponent. Now when I do the derivative, just power rule, move the negative in the front, negative 5. Sorry, move the negative 5 in the front. Subtract 1 from the exponent, negative 6. If I want to stop here, I can. Usually, we want to write it without negative exponents, so let's do that. Done. I just realized this is a function of t, and I said differentiate with respect to x. Let's say x or t to make that make more sense. Third one, f of x is x cubed over 2. Looks like a quotient, but if the bottom is not a function of x, it doesn't have to be treated with the quotient rule. Bring out the 2 so it's a coefficient, 1/2 times x cubed. Now treat it with your constant multiple rule. Do the derivative f prime of x, 1/2, times the derivative of x cubed, 3x squared, or put it together right away as 3/2 x squared. No quotient rule necessary if I can simplify it first. Now the following examples, we need a quotient rule. Sure, I could bring this up and write this as x to the negative 1 times the sine of x, but how much easier did I really make it? Now I'd have to use a product rule. Well, they're both about the same, so let's just forget about it and save our time and leave it as a quotient and use the quotient rule. So let's write down our quotient rule. The derivative of this is the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom function squared. Bottom is x, derivative of the top is cosine x minus top sine x times the derivative of the bottom function. Bottom function is x, so its derivative is 1. All over the bottom function squared, x squared. Done. But not so pretty, so let's simplify a little bit more. X cosine x, because at least I can take away the parentheses, minus sine x, all over x squared, and done and a little bit prettier. How about you try this quotient rule on your own? Pause the video, come back, see how you did. All right, it's a quotient, has to be a quotient. I could make it a product, but I kind of make it a little bit more difficult, involving a rule that really we haven't even done yet. So let's go, starting with our bottom. G f prime minus f g prime over g squared. Okay? Always starting with our bottom. Always starting with our bottom. So g is the bottom, x minus 3. Derivative of the top, 2x plus 5. Minus f, the top, x squared plus 5x, times the derivative of g, the bottom, 1. All divided by the bottom squared. This is a derivative, so we could say done. But we should probably simplify a little bit, so let's do that. I can distribute in this first one. You can FOIL those out a little bit. So 2x squared plus 5x minus 6x minus 15. Over here, distribute the negative at least. Negative x squared minus 5x all over x minus 3 squared. Usually I'm never going to expand the bottom. It's either going to help me by being able to see the factors and I can factor it out, or it's not going to do anything and waste my time. So 2x squared minus x squared is x squared. Positive 5x minus 6x. Minus 15, looks like that's it, over x minus 3 squared. This is definitely the version you'd see if it were multiple choice. Know how to simplify your expressions. Here's another one. Why don't you take a shot at this and come back? You might need a little hint. First of all, yes, we have a top. And yes, we have a bottom. And no, we can't really make it not a quotient. So we have to use the quotient rule. So I'm going to think that I'm planning to do bottom derivative of top minus top derivative of bottom over bottom squared. Bottom, start with the bottom. Always start with the bottom. Not sure why that was scary, but if we try to take the derivative of the top, f prime, notice that within f prime, or within f, I have a product of two other functions. Since I'm already using f and g, let's call these other things maybe u and v. So I'm going to say f prime is one of the functions times the derivative of the other plus the other times the derivative of the first, uv prime plus vu prime. One of them no derivative, one of them derivative, plus, and then vice versa. So that would mean for this, x squared, non-derivative, times sine x's derivative, cosine x, plus sine x, non-derivative, times x squared's derivative. If I want, I can simplify that a little bit, at least so that it doesn't have parentheses. X squared cosine x plus 2x sine x. There's our f prime when we're ready to plug it in there. Let's go ahead and use our quotient rule. So, bottom, start with the bottom. Always start with the bottom. Bottom g is x cubed plus 1. F prime, we wrote it out up there. Let's plug it in here now. X squared cosine x plus 2x sine x minus f. F is the top, the whole top. X squared sine x times the derivative of the bottom. Derivative of the bottom, x cubed plus 1, its derivative is 3x squared. All divided by bottom squared. Lots of bottoms. Lots of bottoms in the quotient rule. If there's a bottom, if it's a quotient, lots of bottoms, lots of bottoms. Start with the bottom, bottom squared, lots of bottoms. We have a derivative. We could stop here. Or if you want to simplify it, go ahead and simplify it. Let's go practice a couple others. All I wanted to show you with this next example, besides what they could look like on an AP exam, is here, is it telling you to take the derivative? Yes, yes it is, in code. What's the instantaneous rate of change? They're asking, what is the derivative? At x equals 2, now they're saying plug in 2. So step 1, find the derivative. Step 2, plug into where x is. Let's do that using the quotient rule. Maybe you pause the video, come back and see if you're correct. So f prime of x. we start with the bottom. Always start with the bottom. X minus 1. Derivative of the top, 2x. Minus, because it's a quotient. Quotient is a shortcut of subtraction. So minus top x squared minus 2 times derivative of x minus 1. The bottom is 1. All over bottom squared. Now we can simplify if we want to, but remember our purpose is to find the derivative at x equals 2. So at this point, in case we don't want to mess up in our algebra, plug in 2, and then all you have to do is number crunch. F prime of 2 means 2 minus 1, 2 times 2. I'm plugging the 2 in for all the x's everywhere. 2 squared minus 2 over 2 minus 1 squared. Let's do the number crunching, and we're done. That's 1. That's a 4. I might as well just keep the same notation. 4 minus 2 looks like 2 times 1 over 2 times 1 is 1 squared. That looks like 4 minus 2 over 1, or 2. Now, just to ease ourselves in to the next video, if you'd like, stop here, go to the next tutorial. You're pretty much done with quotient rule, but I'm going to show you now where the rules from the next tutorial come from. d dx, the derivative with respect to x of this quotient. This quotient, what's another form of this quotient? Sine x divided by cosine x. What's that equivalent to? How's that simplified? Tangent x. So what we're really doing here is the derivative of tangent, but let's do it as a quotient. Using our quotient rule, bottom always goes first. gf prime minus fg prime over g squared. So the derivative is starting with the bottom, cosine x. F prime, the derivative of sine is cosine x, minus f, that's the top, sine x. Derivative of the bottom is negative sine x, over bottom squared, cosine squared x. Cosine times cosine is cosine squared x, minus, a negative is plus, sine squared x, over cosine squared x. Well, hopefully you recognize this is the Pythagorean identity, equivalent to 1. The reciprocal of the cosine function is the secant function. So this is the same as saying secant squared x. Bottom line, what's the derivative with respect to x of the tangent function? Because really, that's what we started with, the tangent function, secant squared x. In the next tutorial, I'm going to show you those last 4 trig derivatives and how to do those quickly without always needing a quotient rule. If you want to see one more, stay for this one. What's the equivalent to 1 over sine x? That's right, cosecant x. So here, we're really taking the derivative of cosecant x, but we're going to do it as a quotient. Bottom times the derivative of the top minus top times the derivative of the bottom over bottom squared. That's 0, so I get negative cosine x over sine squared x.